I'd like to feature an engine that I bought recently. This is my beautiful Stuart Models Victoria steam plant. I saw this model on an internet auction site and I thought, this looks really good. The seller goes by the name of Minnie's Antiques. I'll put the name on the screen so you can see it. The engine was in Cheltenham in Gloucestershire, and as I live near Wakefield in West Yorkshire, that's about 165 miles. But it was well worth the trip because this steam plant is really good. The seller was a very pleasant, agreeable chap and we got on very well. Obviously, because I repair these things, it's not a massive problem had it have not been right. I could buy with confidence from this seller. The listing was good, the photographs were good, and it did have a boiler certificate, which always helps. Plus the listing clearly stated returns accepted. So I couldn't really go wrong. On the boiler certificate it says the date of manufacture was 1983, so it's not a new plant, but it's very well made, really well made. This is a Scotch return tube boiler, and the fire comes down the middle of a water tube first. This coil, by the way, is the superheater or steam dryer, and then it goes back through 3 more flues up the chimney. So really the heat is used twice, and I do find that Scotch return tube boilers are very efficient. Well, as far as steam engine related things are efficient, of course. The steam engine is not perfect, it needs a little TLC. The Scotch return tube boiler is 5 inches in diameter. The steam plant did not include a burner, but there was a very nicely made burner mounting. So I very quickly mounted an old gas burner to it. And this is a terrible burner. It's been in a drawer for quite a long time and I'll never fit it to anything because it does this, it just goes out. And it's quite a small burner and gives out very little in the way of heat. I have several Sievert type blowtorch nozzles. I normally use these for silver soldering, but I made a special adapter so I could fit them to the boiler. The first burner that I tried was too big. It made quite a lot of noise and it seemed to raise steam a little bit too quickly for my liking. Long term, heat of this magnitude wouldn't be good for the boiler's structure. So I just turned the pressure down because with the pressure on full, the noise of it was deafening. I thought to take this opportunity to go around the engine and oil all the moving parts. I've filled the displacement lubricator and everything's looking good. Until this happened. This is the carbon monoxide alarm in the workshop and it's going off. So I shut down the boiler, turned the gas off, then I went outside for some fresh air and took the carbon monoxide detector with me so that it would reset. This clip shows me setting the displacement lubricator. I normally set them 1 turn open. The carbon monoxide detector is now back on the wall and it's not going off at the moment. I've turned the pressure of the gas down. We'll see what happens. And it's going off again. So this gas burner is no good at all. Not for this purpose anyway. The gas burner is far too big, so I fitted the next size down. And I'll see how this goes. There's now sufficient steam to run the engine, and I turn it over a few times just to clear the condensate from the cylinder. This engine has drain cocks that are externally accessible, but I didn't want to open them and get sludge and oil and water all over the baseboard. Well, as you can see, the engine is running, and it's running very well. The boiler is still blowing off as well, which is always a good sign, but I think it's time to turn the heat down. On the boiler certificate it says that the working pressure of this boiler is 60 pounds per square inch. When the steam pressure reaches 60 pounds per square inch, the safety valve blows off, so everything's okay there. This working governor is actually connected to a regulator on the cylinder, but as yet I haven't had time to test it to see whether it truly works. This really is a very nice steam plant. And with the smaller gas burner nozzle fitted, it's still generating too much steam, even though I've turned the gas down. This engine has a crankshaft driven water pump to feed water into the boiler as the engine runs. But there's no water bypass valve, so the pump is filling the boiler all the time. This is probably due to the setting of the ball travel inside the pump. It only actually pumps water into the boiler when the engine is running slowly and the pressure in the boiler is low. And that's a good thing, sort of an automatic feed. I'll stop talking for a while and just let the engine run. there's quite a lot of side-to-side movement of the big end on the crank pin, and I can detect a slight clunk, not to be confused with the clunk as the pump pumps. Health and safety warning, you must never do this. This is really, really stupid. Never put your fingers anywhere near a steam engine whilst it's in motion. You can hear the knock now slowed the video down. This is a good tip. Fit a silicone O-ring and stop the big end from moving about. Or fit a copper washer. This will do the same thing. But the silicone O-ring is possibly better because it will expand and contract. So now I'm hoping that this will take up the slack in the big end and stop that knocking noise. I'll carefully fit the 2BA nut on the crank pin. By the way, I do actually know that this is not the problem, but for the moment I'll carry on anyway. I'm using a piece of brass between the pliers so don't mark the crank pin. That's it, the crank pin's now nice and tight, and as I rotate the flywheel there's hardly any side-to-side play of the big end on the crank pin. I'll just give everything a good coating of oil again and see what happens. And before I run the engine again, I'm changing the blowtorch nozzle. This is the blowtorch nozzle that I use most of the time for silver soldering pipes. So once I clamp this in place, I can light it and see whether it's better. I should think it is because it's a lot smaller than the other two. It's still a bit noisy when it's on full, but I'm hoping that once I raise steam I can turn the pressure down, because the constant roar of a gas blowtorch is not something that I like very much. Well, even the small blowtorch is doing the trick. 30 psi already. Don't forget it's 60 pounds per square inch blow off point. While I'm waiting for the pressure to climb a little bit higher, I'll just check the temperature of the tank. As liquid gas evaporates inside the tank, the pressure drops, so I'm trying to warm up the tank with my hands. And that's done the trick. 60 psi and just about to blow off, there it goes. Once again I'll stop talking so you can hear the engine running. Hello, it's me again. I'm speaking because I can't hear the engine anymore for the noise of the blow lamp. And that of course is always going to be a problem if you're using a blowtorch type of burner. The other option of course is to use a ceramic type burner, and this type of burner sits just inside the centre flue. But I'm not a massive fan of ceramic burners. I don't find them very efficient, and I've done quite a lot of experimentation with them. Ceramic burners make an entirely different type of noise. They set up a resonance down the centre flue, and the centre flue becomes a musical instrument that generates a really bad howling noise. Plus certain types of ceramic burner actually burn out. One exception to the rule was a type that Mike Abbott at Max Steam used for a while. These burners didn't seem to howl hardly at all, but they did have a problem. The gas would suddenly start burning inside the burner and cremate the ceramic. So with this burner I'm changing the ceramic to this type. This is the older type of ceramic that Mike used to use on his early burners. And this is what I mean by the howling noise. If I turn the gas pressure down, the howling disappears, but so does the heat. So I've modified this burner. I've put a hood round it, and I'm just making it so it's just outside the flue and it doesn't howl at all. And I'm getting the benefits of a quiet ceramic burner with none of the howling problems. By the way, I found out what the problem was with the knocking and I've fixed it. See if you can spot what it is. If you can't spot what it is, don't worry, I'm going to do another video showing exactly what I did and how I did it. This ceramic burner modification is definitely successful for this plant. That's about it. I'm going to leave the engine running for a while to the end of the video. So I'd just like to say thanks for watching and I hope you found it useful.